Today we're going to be looking at adding and subtracting polynomials. So there's a few terms that you need to know. Monomial, you're going to see. Think of a monomial as one term. It could be a variable, it could be a number, or it could be a product of numbers and variables. Binomial, of course, would be two terms that you couldn't combine. So for instance, x squared minus 5x. That would be considered a binomial. Two terms. Trinomial has three terms. So when we talk about poly, it just means more than one term. So looking at example 1, we're going to add this trinomial plus another trinomial. Now when we add, we can only add like terms. Now ask yourself in example 1, are these parentheses necessary? If you're adding, if all you're doing is adding, 4 plus 5 is the same as 5 plus 4. So we really don't need these parentheses. So what I'm going to do first is just write out my problem without the parentheses. And then I'm going to collect like terms. So it looks like I have a 3x squared, and I don't have any other x squared. So I'm just going to bring that down as 3x squared. Then I'm going to look for x's. So it looks like I've got a 5x, and I don't have anything else. So I'm just going to bring that down. Now, after I deal with my x's, then alphabetically, the next thing that I see are y's, and I do have some y's. I have 2y minus 7y. So think of that as 2 yo-yos minus 7 yo-yos, which would be a negative 5y. If you start with 2 yo-yos and you lose 7, you're going to end up in the negative 5 yo-yos. And then the last thing that we have, it looks like, is we have a negative 4. Notice I'm always including the sign in front, plus 9. Well, if I lost 4 and gained 9, I'm going to end up with plus 5. Okay, now let's look at example 2. Example 2 is also a trinomial, but this time it's minus an entire trinomial. So we need to subtract that entire trinomial. So those parentheses really are necessary in that second trinomial. Notice in the first trinomial, there's nothing in front except for just an understood 1. So I can bring that first trinomial out of those parentheses. But then it's telling me I need to subtract that entire quantity. So those parentheses are really important for me to realize that's a whole quantity that I'm subtracting. So when you subtract a whole quantity, you're really distributing a negative. And so what is the opposite of a negative 3x squared? That's a positive 3x squared. What is the opposite of 4y? That's minus 4y. And what's the opposite of a negative 3? That is plus 3. Notice the signs just changed. Instead of a negative 3x squared, I have a positive 3x squared. Instead of a positive 4y, I have a negative 4y, or minus 4y. And then instead of a minus 3, I have a positive 3. So when you're distributing a negative, those signs are just changing. Now, I'm going to erase those to help me. I'm going to look for my like terms. So I'm going to start with my x squared and see if I have anything else that is similar. I have 6x squared plus 3x squared, which is 9x squared. Think of x squared as an unknown, like xylophones. So if you had 6 xylophones plus 3 xylophones, you're going to get 9 xylophones. Notice the x squared does not change when you're adding. It's just like when you do 6x plus 3x is 9x. The x part doesn't change when you're adding or subtracting for that matter. All right, now let's look for, I've got some y's. I have a negative 2y minus 4y. So if I lose 2 yo-yos and I lose 4 more yo-yos, I've lost 6 yo-yos. And then the final thing I need to look at is I've got a 4 plus a 3, and I can combine 4 plus 3 normally. It's just plus 7. And then that's my answer.